All right, and welcome to 6-2.5, right triangle practice. Now, in this very first example, it says given AB is perpendicular to BC. That's what we've been missing in a lot of these. And AC is 18 feet, so I see AC is 18. And angle BCA, so notice that the vertex is here is C, so BCA is going to be 14 degrees. Find the measure of BC. Let's go ahead and put an X there. All right, what are we going to do in this problem? Well, when we have an angle and a side, we want to use our trigonometry. So we draw our arrow, we point it to this, the hypotenuse, we circle our relevant angle, and we know that the side that goes into the circled relevant angle is our adjacent, which by default makes that the opposite. Now we ask ourselves, which one of these three pieces of information do we just not need? And of course the answer is we don't need the opposite. Okay, so which one of our three trigonometric functions uses the adjacent and the hypotenuse? Well, of course that will be cosine theta, which is equal to the adjacent over the hypotenuse. Now let's go ahead and fill in all of our information. And so we can say, okay, you know what? We have the cosine of 14 degrees is equal to the adjacent x over 18. And I'll even give you our very first step. Remember, you always multiply by the denominator, or what's on the bottom, and so we'll multiply both sides by 18. Now from there, whatever 18 times the cosine of 14 is will equal to x. And just make sure that in your Desmos scientific calculator, you have that in degrees. All right, so let's move on to our second example. Okay, for example number 12. Let's see, given AB is perpendicular to BC, so we know we have a right angle. AC is 25 units, and angle CAB, let's see, C to A to B is going to be 58 degrees. Find the measure of BC. All right, well, once again, let's go ahead and do our labeling. We know we're going to point our arrow to the hypotenuse. We circle our relevant angle, which labels the adjacent. And of course, our default third side is the opposite. Now, when we look here, we ask ourselves, which one of these three pieces of information do we not need? Of course, it's the adjacent. And which one of our trigonometric functions actually utilizes the hypotenuse and the opposite? Well, of course, that will be the sine theta, which is equal to the opposite over the hypotenuse. Now, if we fill in everything, of course, our angle is 58 degrees, our theta, and that will equal the x over 25. Now, I'm going to stop right there because you solved this the exact same way as you did the previous problem. So, go back and check that. Remember, this problem is telling you to input the value to the nearest tenth. All right, so be careful if you have to round. Okay, for problem 13. Of course, we are given AB is perpendicular to BC, as always. We're given AC is 17 and BC is 18. And wait a second, in this one, we want to find the measure of angle BAC. We want to find our theta. Now, this is interesting. Let's go ahead and start this off as we normally would. We'll draw our arrow, which points to the hypotenuse. We'll circle our relevant angle, which gives us the adjacent. And of course, the 18 is our opposite. Now, since the hypotenuse doesn't have any relevant information, we can cross it out and ask ourselves which one of our three functions uses the opposite and the adjacent. And of course, that will be the tangent theta, which is equal to the opposite over the adjacent. Now, this is an unusual case. Let's fill in everything as we see it. We'll say, okay, you know what? Our tangent of theta, we don't know what the angle is equal to our opposite, which is 18 over 17. And this is something that we're just going to learn right now. To get rid of this tangent so we can get the theta by itself, you take what's called the tangent inverse. It's where you write tan to the -1, and you just, basically, it cancels out the tangent. Now on the right side, we put the whole right side in parentheses, and we write the same thing, the tangent inverse. And what we'll notice is we have this theta is equal to the tangent inverse of our original 18 over 17. Now, how do you type this in? Well, you'll have to type this into your Desmos scientific calculator, and you'll see a button that says function. So push that, and when you push that, it will give you the choice to push tangent inverse, okay? And so then you'll type this exactly as you see it into the calculator, and you'll get that theta. All right? Good luck, and let's move on to our next problem. Okay, here we have a very serious problem. It says solve for the length of dA given BC is an altitude. Okay, so let's kind of really set up what are the things that this is asking us for. So firstly, it's asking us to find the length of dA. So it's asking us to find this entire length. Okay, and notice we're also given that this is an altitude. So the first thing I say, you know what, at the end product, if I were to call this segment A and this segment B and this segment C the altitude, I know that I have my geometric mean. A times B is equal to C squared. Now let's put that on pause though, because for us to use this formula, we have to know either A or B. Well, using my, let's just say using this nice blue color, we can actually isolate this triangle on the right side. And if CB is an altitude, that means that that's a right angle. What does that mean? It means that we can take this right angle and draw it out over here, where this is 32 degrees and this is 12, and we want to find this. I'll call it letter B this time. Okay, so we can do all of our labeling. I'll draw my arrow, there's my hypotenuse, circle my angle, there's my adjacent, and of course there's my tangent. Of course the hypotenuse is kind of worthless, and so we'll go ahead and do this. We'll say, you know what, we have the tangent. Oh, I'm sorry, that's my opposite. I'm getting ahead of myself. There's our opposite side. So we have the tangent of 32 is equal to our opposite 12 over our adjacent, the letter B. Now this is our more difficult trigonometric situation. So what do we want to do here? Well, we always start the same way. We start by multiplying by what's in the denominator. So I'm going to multiply both sides times B, and we now have this. We now have B tangent of 32 is equal to 12. Of course, that goes away. Now from here, what are we going to do? Well, we're actually going to divide both sides by the tangent of 32. We'll divide both sides by the tangent. Now I have to be very careful. My little pause button's there. By the tangent of 32. Alright? Now from there, notice that goes away. And let me write this a little bit cleaner. We have B is equal to the tangent, B is equal to 12 divided by the tangent of 32. And if you go type that into a calculator, you will get some sort of value. Alright, I'll let you do that. But whatever that is, we will then take and plug that back into there. Alright, and you know what, let me go ahead and find B just so it can go just a little further into this problem. Okay, so it looks like B is equal to 19.20. I found that by going to my calculator. And now, how do we set this problem up? Well, we'll say our A value, we don't know that, times our B value, which wound up being that 19.20, is equal to our C value squared, or 12 squared. Alright, and I will leave you to solve that on your own. Good luck. Okay, here we have our final problem. It says solve for the area of the triangle below. So we're going to have to know some things. We're going to have to know at the very end of this, we'll have to use the area of a triangle, which is equal to 1/2 the base times the height. Okay, so that's something to keep in mind. And notice, for us to find the area, we have the height here, we have the h, but we need to go ahead and find the entire base. And in order to do this, we'll actually have to utilize our geometric mean. We'll have to find, let's call this x, and let's call that y. Now you might be thinking, okay, let's use some trigonometry, but I want to go ahead and really highlight this triangle here on the right. We know it's a right triangle like that. And I could draw it like this. I could say, okay, well, there's the 45 degrees, there's the right angle. And wait a second, if we were to subtract both of these numbers from 180, 90, and 45, we would also get 45. You'll notice that this right here is actually a 45, 45, 90 right triangle. Or you could even notice that the base angles are the same, and so if it's also an isosceles triangle. So if this is 20, then guess what? X must also be 20. We can say x is equal to 20. Now from there, now we can go ahead and use our geometric mean formula. The way that I've set this up, so let's use x, y, and h, we could say that x times y is equal to h squared. Or in this case, our y value we don't know. Our x value we found out was 20, so we could say 20 times y is equal to, and our h value is 20 squared, and now we could solve for y. And so let's see, 20 times y is 20y is equal to 20 squared is 400. And we would simply divide both sides by 20. And wait a second, 400 divided by 20 is 20. So even though it doesn't look like it, this is actually both the left and right side of this triangle would actually be the exact same lengths. Now from here, we know that 20 plus 20 will give us a base of 40. And I will now leave you to finish the problem on your own. Here's our base, here's our height, and good luck.